So what we learned so far? We start talking about different variables. Variables in statistics can categorize into discrete or continuous. When we're talking about discrete variables, it means that they are countable. We can count them. For example, the number of students sitting in this class, attending this class. Can we count them? Of course. One student, no student, two students, three students, and so on. Discrete or countable, and we have another type of variable that we call continuous variable. Continuous variables, they can take on values in between two values, and they can form an interval. For example, volume, area, height, weight, and so on. Those are examples of continuous variables. Well, why this is important for us? Because when we have different variables, we're going to work with different types of probabilities. We denote each variable using either x or y or different types of variables that we can use to represent a variable. And the probability of variable x by p of x. So when you see p of x, it means that you're finding the probability of variable x. Well, when we have discrete variable, we have different type of variable, type of probability than probability for a continuous random variable. So let us rewrite this. Variables, they have discrete variable and continuous variable. For a discrete variable, the probability of variable x is denoted by p of x, and the probability of a continuous variable x is also denoted by p of x. So it's very important when you're talking about probability of a variable like x, mention that x is discrete. When you're talking about probability of variable x and x is continuous, you have to mention that x is a continuous variable. One of the famous discrete random variable and discrete experiment is binomial experiment. One of the most important discrete experiment is binomial experiment. So when you have a binomial experiment, you can identify that by the following properties. First of all, you have a fixed numbers of tries. It's denoted by n. For example, you're a surgeon and you have 10 surgeries. N is equal to 10. 2, these experiments are independent from each other. It means that when we are doing the experiments, when we're performing the experiment, they have no dependency. The keyword that you see in an example or in a question is with replacement. So the keyword with replacement guarantee that the experiments are independent from each other. 3, each experiment has only 2 outcomes. It's either a success or it's a failure. 2 possible outcomes. Success or failure. The probability of success is denoted by P, and the probability of failure is denoted by Q, which is 1 minus P. And finally, your random variable X counts the number of successful tries. Counts the number of successes. So as we mentioned before, it's denoted by P of X. So again, we have 2 types of variables, discrete and continuous. The probability of discrete random variable is denoted by P of X, and one of the important discrete experiments is binomial. For binomial experiments, we can define the probability of variable X, which is equals to n factorial divided by x factorial times n minus x factorial times p to the x q raised to n minus x. So what is factorial? What is this symbol? exclamation mark. In math, we call this symbol factorial. When do we use factorial? What's the meaning of that? So suppose you have numbers and you're trying to multiply those numbers. For example, you're multiplying 2 and 1. Of course, you know the result is equal to 2. Then you're interested in multiplying 1, 2, and 3. Of course, you know the result is 6. What if you start multiplying 1 by 2, by 3, by 4? What if you start multiplying 1 by 2, by 3, by 4, by 5? Continue this process. 1 multiplied by 2, multiplied by 3, by 4, by 5, by 6, and continue this process. You're multiplying 1, 2, 3, 4, 5, 6, 7, 8, and you stop at n. For simplicity, we use factorial symbol to represent these multiplications. 1 times 2 is 2 factorial. 1 times 2 times 3 is denoted by 3 factorial. 1 times 2 times 3 times 4 is denoted by 4 factorial. As you guessed, this multiplication is represented by 5 factorial. Here you have 6 factorial. And you can continue this process. Since the last number is n, you have n factorial. So when you see n factorial, the meaning of n factorial is that you're multiplying 1 by 2, by 3, by 4, and the rest of the numbers in the middle by n. So this formula here is called the combination of x values, x numbers taken from n numbers and objects at time. Combination of x objects taken from n objects is n factorial divided by x factorial n minus x factorial. We usually denote this by x taken from n, and this is called the combination. Sometimes you see c n comma x, or you see c x out of n. So either of these notations represent a combination of x objects taken from n objects. Combination. We can replace this fraction by either of these representations. X taken from n, c of n comma x, or c of x out of n. So now that we talked about a binomial experiment, let's get back to a discrete random variable and talk about the graph of probability distribution for a discrete random variable. So for a discrete random variable, we have probability of variable x denoted by p of x. Now I expect you to ask, what if we want to find the probability of x to be less than a value, x greater than a value? What if we want to find the probability that x is bounded between two other numbers? So for each probability, we have different cases. This probability can be, find the probability that x is exactly equals to a value like a. Or you might be interested in finding the probability that x is less than or equals to a. Or you might see a question that asking you to find the probability of x to be greater than a number like, let's just write it b, then change this to a. Or you might be interested in finding the probability that x is bounded between two values. How do you calculate these probabilities? To find each of these probabilities, let us take a look at a probability distribution graph and try to analyze this. For each probability distribution, when you're talking about probability distribution, in this case, you're focusing on discrete random variables. So let us write down, you're talking about discrete random variable x. We have a histogram, relative frequency histogram. Well, suppose your relative frequency histogram is given as follows. On the horizontal axis, remember that we have x, random variable x, and on the vertical axis, you have p of x, the probability of variable x. And since it's a histogram, remember that we have some bars. X equals to 0, x equals to 1, x equals to 2, x equals to 3, 4, 5, 6, 7, and so on. And suppose we have the following bars. The probability that x is equal to 0, the probability that x is equal to 1, the probability that x is equal to 2, the probability that x is equal to 3, probability that x is equal to 4, probability that x is equal to 5, probability that x is equal to 6, and the probability that x is equal to 7. Suppose the maximum probability is equal to, let's say, 50%. And let us have this as 25%. And we can approximate these using just these bars. Well, suppose I ask you to find the probability that x is exactly 3. Suppose I ask you to find the probability that x is less than or equals to 5. Suppose the question says, find the probability that x is greater than, let's say, 2. And finally, find the probability that x is bounded between 2 and 5. How do we calculate these probabilities? To calculate each of these probabilities, we look at the graph that we have here. Each of these bars are representing the probability. The first one says, what is the probability that x be exactly equal to 3? Well, x is equal to 3. Its probability is 50%. Suppose this 50% is just right here. So you say the probability that x be exactly 3 is 50%. 0.50 or 50%. Now, what if the question says, find the probability that x is less than or equal to 5? What's the meaning of that? It means that x can be 5, x can be 4, it can be 3, it can be 2, it can be 1, and it can be 0. So we can write it as the probability that x is equal to 0 plus the probability that x is 1 plus the probability that x is 2 plus the probability that x is 3 plus the probability that x is 4 plus the probability that x is 5. Since we have the probability for each of these cases, we can easily find the probabilities, approximate them, and add them all together. What if the question says, find the probability that x is absolutely greater than 2? There is no equality here. It means that x can be 3, or 4, or 5, or 6, or 7. So we need to find the probability that x is equal to 3 plus the probability that x is 4 plus the probability that x is 5 plus the probability that x is 6 and add it to the probability that x is 7. Well, what if the question says find the probability that x is bounded between 2 and 5? It means that we need to find the probability that x is 2, add it to the probability that x is 3, plus the probability that x is 4, plus the probability that x is exactly 5. By using our graph, the probability distribution, we can approximate each of these probabilities and add them all together.